Good morning, everyone, and good morning to you also, Sir Greggy, our professor for this course, Physiological Psychology. Today, our group will be presenting the topic internal regulation. But before we start, I have a question for everyone listening or watching this video. So that question is, have you heard the term internal regulation? If not, internal regulation refers to how the brain and body work together to keep everything balanced and working properly. Again, internal regulation refers to how the body and the brain work together to keep everything balanced and working properly. Now that we have learned the definition of internal regulation, I will also be giving you guys real-life examples for us to fully understand what internal regulation is. So, in this picture, we can see that a woman is wiping her body or wiping her sweat. Actually, guys, for some of us, sweat is more like dirt sa atong lawas. But in internal regulation, sweat actually helps our body to cool down and give our body back to its normal temperature, which is at 37 degrees Celsius. So naaday ni siya pangan kaning process na nag-cool down itong lawas with the use of sweat. Ang process ana niya nagitawag sa internal regulation is actually called thermoregulation. Another example, guys, is as we can see in the picture, a man is drinking water or he is thirsty. Maybe because gikan siya nag-jogging, gikan siya nag-swimming, or gikan siya nag-exercise. Mo nang giuhaw siya or he is thirsty. And by being thirsty, guys, it tells our body that it needs water to be balanced. For the brain, detects low water levels and triggers thirst. So imagine if we are thirsty or our body needs water, our brain actually sends signals that it needs water for our body to keep balance or to stay balanced. So again, what is internal regulation? Internal regulation, again, guys, refers to how the brain and body work together to keep everything balanced and working properly. So in the next slide, we will be talking about the two subtypes or the two subgroups of internal regulation, which are the homeostasis and the allostasis. But first, we will be talking about what homeostasis is. So homeostasis, guys, refers to the body's way of keeping things balanced or stable inside even when things change outside. So again, akong i-repeat, homeostasis refers to the body's way of keeping things balanced or stable inside bisan pa things outside change. Like for example, it keeps our temperature, heart rate, blood sugar at the right levels so everything works properly. So, mahatag ko ninyo og example, guys, na what homeostasis is really about para makasabot mo. So, an example of homeostasis na makasabot mo is that mura siya thermostat sa atong bay, which is nag-keep og temperature in a right jud na temperature sa atong bay. So, for example, very bugnaw sa gawas or very init sa gawas sa atong bay, ang thermostat mooy nag-keep sa atong balay o balance iyahang temperature. So, mao na ang homeostasis. Despite na nag-change ang weather or nagdaghan kay external changes sa outside, ang homeostasis mooy nag-keep og balance or nag-keep siya og stability inside sa atong body, like the thermostat sa atong house. Now that we have tackled what homeostasis is, let's go to allostasis. So what is allostasis, guys? Allostasis is just like homeostasis but with a twist. So what is that twist? Allostasis is actively adjusting our body to stress or to change for it to to stay stable in the long run. So again, allostasis is actively adjusting our body to stress or to change in order for it to stay stable in the long run. If sa homeostasis, keeping our body balanced, sa allostasis, it is changing or adjusting our body to change. Like for example, katong sa thermostat, diba, kay balance siya, nag-balance siya og kanang temperature sa bay bisan pag init sa gawas. Sa allostasis, the thermostat will already adjust its temperature before you go home, diba? So like before you go home sa inyong balay. This is because in allostasis, it studies your schedule, when will you go home or when you leave the house. So, murag naka-adjust na ang allostasis. So, nga ni oras sa example, init kayo inag-ubto, 12 noon. So, murag sa allostasis, nakahibaw na siya na so, kani siya muli siya mga 11. Ako nang i-adjust ang thermostat or ang temperature sa bay into murag bugnaw-bugnaw gamay. Para iniguli niya, more comfortable na siya, ana ang allostasis, mo adjust na siya, mo actively adjust na siya for our body to stay stable in the long run. So again, mo na ang difference niya. Homeostasis again is keeping things balanced or stable inside even when things change outside. In allostasis, actively changing to stress or to change in order for the body to be stable in the long run. And now we're here with temperature regulation. So what is temperature regulation? Temperature regulation is how your body keeps its internal temperature in a healthy range. Again, temperature regulation is how your body keeps its internal temperature in a healthy range. Usually around 37 degrees Celsius. Mauna na ang murag normal bitaw or healthy range ato ang temperature. So again, unsa ang healthy na or normal range atong temperature? 37 degrees Celsius. Even though if it's hot or cold in the outside, temperature regulation mo jud na siya ang nag-keep sa atong internal temperature in its healthy range. And did you guys know that temperature regulation is also part of homeostasis, and that our brain or our body has also a thermostat? So guys, what do you think ang thermostat sa ato ang brain? Unsa day na thermostat, diba? Thermostat is what keeps our temperature regulated or balanced nga na ang thermostat. Naa-de po thermostat sa ato ang brain. And what is that, guys? Actually, it is our hypothalamus. It is considered as our thermostat sa ato ang brain, for it is like our body's internal climate control system. And temperature regulation is a critical function that allows the body to maintain a stable internal environment, ensuring that biological processes function optimally. This process is primarily controlled by the preoptic area or anterior hypothalamus, POA or AH in the brain. And now guys, naa na ta sa brain mechanisms. So, what are brain mechanisms? Unsay meaning sa brain mechanisms? Brain mechanisms are actually the parts of the brain that help control our body temperature. So again, brain mechanisms are parts of the brain that help control our body temperature. So there are actually two parts sa brain na nag-help o control sa atong body temperature, which are the anterior hypothalamus and the preoptic area. They are like our body's built-in thermostat. And these two, the anterior hypothalamus and the preoptic area, are located near the optic chiasm, which our eye nerves cross. That is why it is called the preoptic area. So again, nganong gitawag siya as preoptic area? Because ani na part sa preoptic area nag-meet or nag-cross ang eye nerves nato. Again, moona siya gitawag as preoptic area. It is because ana nag-cross or nag-meet ato ang eye nerves. So I will be giving you examples on how the anterior hypothalamus and the preoptic area work in controlling our body's temperature. Ang example ani is when they get messages from our skin or inside our body about how hot or how cold it is. Ang ilahang job as brain mechanisms is muingon sila sa body or mohatag silang signals sa body what to do. Again, as brain mechanisms, mohatag silang signals sa ato ang body on what to do, on how to control or how to keep our body temperature regulated. Mao na siya ang brain mechanisms. So, if it is too hot, our brain mechanisms send signals to make our body sweat to cool down. So, mo to akong i-explain or yatagan mo example ganiha. Kato bitawang nag-sweat. Actually, dili siya some misconception. Ang sweat daw is murag dirt. Pero actually, sweat actually helps us in cooling down. Mo na siya. So, again, balik ta sa brain mechanisms. Ang brain mechanisms, if it's too hot, mooy mo signal sa atong body to sweat para mo cool down atong lawas. And if it's too cold, our body is too cold, mo send pod og signals ang brain mechanism na mag-shiver ato ang lawas, magkurog-kurog to keep blood away from our skin to keep heat inside. So again, mooy ang work or moo ang gamit sa brain mechanisms. Ang part sila sa brain na mo help, na mo hatag og signal sa ato ang body on what to do, on how to keep our body temperature regulated or how to keep our body temperature in control. So now I will be giving the floor to my fellow groupmate, Miss Carmel Abucejo, to report the next topic. Thank you.
Thirst mechanisms and types of thirst. Introduction to thirst. Water in the body. Water constitutes about 70% of the mammalian body. Importance of water. Explain that water is critical for maintaining chemical reactions in the body. It acts as a solvent for chemical or biochemical processes and helps transport functional chemicals throughout cells and tissues. And for survival, you can survive weeks without food but only days without water. And we have its key functions of water: maintains our normal blood pressure, supports our circulatory system, and regulates body temperature. Next is mechanisms of water regulations. Species differences. We have the beavers. Beavers drink plenty of water, eat moist food, and dilute or excrete dilute urine. Gerbils. Gerbils survive without drinking and they gain water from food and excrete dry, feces, and concentrated urine. And last, we have humans. Humans adjust strategy based on availability of water. Next is how humans conserve water. We have the vasopressin, a hormone released by the posterior pituitary to conserve water. Vasopressin, also known as antidiuretic hormone or ADH, highlight its importance in maintaining water balance in the body of regulating water. And blood pressure. Mention that it's produced in the hypothalamus and released by the posterior pituitary gland. And we have the actions of vasopressin. Vasopressin raises blood pressure by constricting blood vessels and enables kidneys to reabsorb water, making urine more concentrated. And it is also said that vasopressin increases during our nighttime. And last is osmotic thirst. Osmotic thirst occurs after eating salty foods like junk foods. And its mechanism, Salt increases osmotic pressures outside cells, causing water to flow out of cells. Neurons detect dehydrations and trigger thirst. And lastly, is kidney excrete more concentrated urine to rid the body of excess sodium. And the next reporter will be Chanel, and she will all be tackle about osmotic thirst.
Okay, so for our next topic is osmotic thirst. Osmotic thirst happens when your body loses water but not salt, making your blood more concentrated or salty. Your brain detects this and tells you to drink pure water to fix the balance. So how the brain detects osmotic thirst? Receptors near the third ventricle, like the OVLT, organum vasculosum of the lamina terminalis, and the SFO, or subphonical organ, monitor balance of salt and water in the blood. These receptors don't have a blood-brain barrier, so they can directly sense changes in osmotic pressure. They also get input from the digestive system to anticipate changes, like when you eat salty food. For real-life example, mukhaon ka junk foods and then you might feel really thirsty a few minutes after. This is osmotic thirst kicking in. The salt draws water out of your cells, making your blood saltier. The brain's receptors in the OVLT and SFO detect this, and you get the urge to drink water to dilute the salt. And another example is after you sweat a lot and not drinking water, sweat removes more water than salt from your body. Your blood becomes concentrated with salt, again triggering the osmotic thirst. So for the analogy of this whole topic, think of your body like a soup. If you boil away the water, like losing water through sweat or urine, but you keep the salt, the soup becomes too salty and your brain wants to add water by making you thirsty to fix the recipe. Okay, so our next slide is hypovolemic thirst, when your body loses volume, not just water. What is hypovolemic thirst? This kind of thirst happens when your body loses both water and salt, like through bleeding, vomiting, diarrhea, or heavy sweating. It's not just about fixing saltiness, it's about replacing lost fluid volume to keep blood pressure stable. So, binali siya sa osmotic thirst, which is water. Ang kaning hypovolemic is both water jud ug salt. So, how it works? Blood volume drops. Sensors and blood vessels detect the decrease. Body responds by releasing vasopressin and helps retain water. Releasing renin, an enzyme from the kidneys, and renin triggers angiotensin II production, constricts blood vessels to raise blood pressure, stimulates thirst and salt appetite to restore lost fluids and electrolytes. Real life example, losing blood. So, for example, masamat ka, syempre mag-bleed na. So when you bleed, you lose both water and salt. The brain senses the lower blood volume and pressure you to drink to restore a total fluid levels. Another example is kana magtay-tay ka or like magsuka-suka ka, you're losing fluids and electrolytes, which triggers hypovolemic thirst. That's why sports drinks with electrolytes help more than plain water. So for our next slide, sodium-specific hunger, when your body craves salt, not just water. So thirst versus hunger. In hypovolemic thirst, the body needs both water and salt. Sometimes, your body especially needs salt. That's when sodium-specific hungers kick in. What is sodium-specific hunger? When your sodium levels drop too low after heavy sweating or vomiting or diarrhea, your body develops a strong craving for salty foods. This is a biological response, not just a preference. How the brain and body responds. Neurons in the brain, especially in the hypothalamus, become more sensitive to salty taste, making salty food more appealing. You feel motivated to seek out and eat salty things like chips, pretzels, or broth. Hormonal regulation. Aldosterone from adrenal glands signals kidney to retain sodium. Angiotensin 2 triggers both thirst and salt hunger, making sure you replace what's lost. For example, after intense exercise or heat exposure, you may crave a sports drink or salty snacks. This is not just a random, your body knows it needs sodium back. After being sick, for another example, vomiting or diarrhea, people often crave salty soup or crackers. Again, it's your body guiding you to restore sodium balance. Analogy? Imagine sodium as a key ingredient on your body's recipe. If the salt runs low, your internal chef, the brain, start demanding saltier ingredients to balance the meal again. So, for our next slide, let's talk about the allostasis and thirst regulation. The body's way of planning ahead to stay balanced. So, what is allostasis? Allostasis means the body doesn't just react, it predicts and prepares for future needs. It helps maintain balance before things go out of control. Anticipatory thirst. Sometimes you feel thirsty before you actually dehydrated. For example, you might feel thirsty before bedtime due to your circadian rhythm, a natural increase in vasopressin, a hormone that conserves water while you sleep. It's your body saying, hey, let's hydrate now so we don't run into problems later. Stopping thirst. After drinking water, you stop feeling thirsty before your blood is actually hydrated. That's because your brain receives quick signals from your mouth, throat, and stomach, a way to prevent overdrinking. This also helps regulate body temperature, important after exercise or being in heat. Real life examples. Drinking before going to bed, katahong iyon ganina. You may not be able dehydrated yet, but your body is preparing for hours without water. Siyempre kay matulog naman ta. And next example is drinking during exercise breaks. Your thirst may stop quickly, but full hydration happens later. Your body just wants to prevent you from drinking too much or too fast. Analogy, think of your body like a smart thermostat. It turns the AC or heat in before temperature actually drops or rises too much. That's allostasis, smart balance in advance. That's all for my part.
Good afternoon, everyone. So I will discuss about hunger regulation. Hunger regulation refers to the body mechanism that control food intake to maintain energy balance, and it involves both short-term and long-term factors that influence when and how much we eat. For example, when your blood sugar drops after not eating for several hours, your body releases the hormone ghrelin, which signals your brain to create the sensation of hunger. Next is digestion and food selection. Digestion is the process by which the body breaks down food into smaller components like nutrients that can be absorbed and used for energy, growth, and repair. It starts in the mouth and continues through the stomach and intestines. Food selection refers to the choices individuals make about what foods to eat, influenced by factors like taste, culture, health, availability, and personal preference. For example, you choose to eat a banana for a food selection because you like to taste and it's convenient. Once eaten, your digestive system breaks it down into glucose, fiber, and the other nutrients your body can absorb and use digestion. Consumption of dairy products. It refers to eating or drinking food made from milk such as cheese, yogurt, butter, and milk itself. Dairy is a key source of nutrients like calcium, protein, vitamin D, and potassium, which are important for bone health, muscle function, and overall growth. For example, drinking a glass of milk with breakfast provides calcium and protein. It's help strengthen bones and keep you full longer. For food selection and behavior, refers to the choices people make about what to eat and the behaviors surrounding eating influenced by personal preference, culture, emotions, health belief, and social or environmental factors. A food selection: if a person may choose a salad over fast food because they're trying to eat healthier, or they might eat comfort food like ice cream when feeling stressed. Next is about short-term and long-term regulation of feeding. First, short-term controls hunger and satiety on a meal-to-meal basis. It is influenced by signals like stomach strength, blood glucose levels, and gut hormones. For example, when you feel full and stop eating during lunch because your stomach stretches and releases hormones that signals sanity to your brain. For a long term, maintains energy balance over time by regulating body weight and fat stores. Hormones like leptin from fat cells and insulin play a key role. And for the example of the long term, if body fat decreases, leptin levels drop, making you feel hungrier over several days to restore fat reserves. The stomach and intestine. Stomach, a muscular organ that temporarily stores food and begins digestion, especially of proteins using stomach acid and enzymes. When you eat chicken, your stomach releases acid and enzyme like pepsin to start break down the protein. And for the intestine, divided into the small intestine where most digestion and nutrient absorption occurs, and the large intestine which absorb water and form waste. For example, after the stomach processes the chicken, it moves to the smaller intestine where nutrients like amino acid are absorbed into the bloodstream. Next is all about glucose, insulin, and glucagon. Glucose, a type of sugar that is the main source of energy for body cells. It comes from the food we eat, especially carbohydrates. After eating rice, carbohydrates are breaking down into glucose, which enters in the bloodstream of energy. And insulin, a hormone releases by the pancreas when blood glucose levels are high. It helps cells absorb glucose and lower blood sugar levels. For example, after a meal, insulin helps move glucose from the body into your muscle and liver for storage or energy use. And glucagon, another hormone from the pancreas, released when blood sugar is low. It signals that the liver store glucose into the bloodstream. For example, if you skip breakfast, glucagon causes the liver to release glucose to keep your energy levels steady. A hormone that they named leptin from the Greek word leptos means slender is a hormone produced by fat adipose tissue that helps regulate body weight by controlling appetite and energy balance. For example of leptin, after several days of overeating, fat cells produce more leptin. This signals the brain to suppress appetite and boost metabolism to prevent future weight gain. So that's all about sa topic. And the next to report is Miss Geraldine for about brain mechanism.
Good day, sir. Good day, classmates. Me and Zelia have this topic, hunger regulation, and I'm on the second part. The brain's role in hunger or hypothalamus. We have the arcuate nucleus. It contains hunger and satiety neurons, stimulated by ghrelin, the hunger, and leptin, insulin, or CCK, which is the fullness. Example is when you feel extra hungry before lunch because of rising ghrelin levels. Lateral hypothalamus. It stimulates eating, enhances taste, helps with swallowing, and promotes digestion. Example, food smells amazing when you're really hungry. This brain part makes it more appealing. And we have ventromedial hypothalamus. It inhibits eating. Damage in this area can cause overeating. Example, lab animals with damage here eat excessively and gain weight rapidly. The next topic is about eating disorders and environmental factors. First, we have obesity. Obesity can be caused by genetics, monogenic or polygenic, or can be caused by environmental factors like consuming high-calorie diets. Example, people genetically adapted to famine may gain weight easily in modern food-rich environments. Second is bulimia nervosa. Binge splurge cycles, often with increased ghrelin levels. Example, a student who secretly eats large amounts might probably vomit after. Third is anorexia nervosa, the fear of gaining weight resulting to extreme diet or exercise habits. Example is when a teen avoiding meals and obsessively exercising due to body image issues. Hunger is a complex process regulated by both biological and environmental factors. Understanding it helps promote healthy habits and prevent disorders. That's all for our presentation. Thank you for taking the time to listen, and we hope you learned something from our topic, internal regulation. Thank you.